Hello everyone, Dr. Polaris here. I'm pretty sure that almost everyone watching this video will be familiar with the KPG extinction event. That time roughly 66 million years ago, when an asteroid the size of Mount Everest slammed into the Gulf of Mexico, unleashing a cataclysmic series of ecological disasters, including global wildfires, tsunamis, acid rain, and perhaps several years of darkness. All terrestrial plants perished in the charred, gloomy hellscape that emerged in the immediate aftermath of the impact, with all modern land-based angiosperms and gymnosperms being the descendants of seeds hidden in the late Maastrichtian soil. With the floral communities devastated, the vast majority of animals larger than a house cat died out, with the only real exceptions being the freshwater and estuarine crocodiliforms, as well as the vaguely similar Choristoderans. Famously, all non-avian dinosaurs perished at this time, alongside a diverse array of non-placental mammals, the vast majority of marine reptiles, and the formerly numerous archaic members of Avialae. Overall, an estimated 75% of all species became extinct, being the second worst mass extinction in Earth's history, just behind the one at the end of the Permian. However, this was not the only time of intense environmental stress during the Mesozoic, with the non-avian dinosaurs and their contemporaries surviving multiple such episodes. This video will be covering two of these, which in my opinion don't receive anywhere near enough attention. First on our list is the Tithonian Extinction event, which took place at the very end of the Jurassic roughly 143 million years ago. Although this event was relatively minor and selective when compared to other extinctions since the Cambrian, it is still noteworthy despite receiving limited formal study. The potential causes of this downturn are still controversial, although the overall global climate of the Tithonian was notably cooler and drier than the preceding Kimmeridgian, leading to a drop in sea levels that appears to have heavily impacted low-latitude, shallow marine shelf-dwelling faunas. In addition, the Tithonian was witness to extended periods of volcanism as a result of the early fragmentation of Gondwana, as well as the explosive origin of the Shaktsi Rise in the Pacific. It has also been postulated that three relatively major impact craters located in Gondwana may have also contributed to the Tithonian extinction, although the destructive effects of these impactors would have still been fairly localised. It has also been suggested that this apparent extinction event may largely be an illusion created by gaps in the fossil record and poor sampling, although recent studies have corrected for this possibility and have still found that an ecological downturn occurred regardless. It is currently debated as to just how severe this extinction may have been, with some estimates finding a loss of 20% of all marine species. Laurasian shallow water marine animals seem to have been hit the hardest, with European bivalve diversity declining sharply going into the Cretaceous. Similarly, more moderate drops in diversity have been observed in gastropods, brachiopods, crustaceans and corals, with many of the Jurassic coral reefs declining to be replaced by Cretaceous rudist-built reefs. Ray-finned fishes also experienced a fall in numbers, but bounced back in the early Cretaceous, while the sharks and rays appear to have been largely unaffected. Marine turtles, as well as the cryptoclidid plesiosaurs, were hit hard as well, with this probably being due to the faunal turnovers associated with reef ecosystems. While the latter group had been common and diverse during the late Jurassic, only a few species persisted into the early Cretaceous, which allowed for the diversification of the more derived elasmosaurids, which would thrive until the end of the Cretaceous. Other groups passed through the event relatively unscathed, including the ichthyosaurs and marine metriorhynchoid crocodiliforms, although the European populations of the gharial-like teleosauroids completely vanish at this time. On land, mammals and lissamphibians underwent minor declines, with the more archaic mammalia forms gradually declining in the early Cretaceous, to be replaced by more derived groups such as multituberculates and eutriconodonts. Pterosaurs underwent a staggered decline at the Jurassic-Cretaceous boundary, with the majority of non-pterodactyloid pterosaurs, such as the long-tailed rhamphorhynchoids, becoming extinct, while the short-tailed pterodactyloids diversified greatly after the Tithonian extinction event. Among non-avian dinosaurs, medium to large-sized theropods with cosmopolitan distribution suffered the most, with ceratosaurids, allosaurids and megalosaurids all dying out at this time, although I couldn't find any definitive reason why. Meanwhile, Coelurosaurs and ancestral Carcharodontosaurids were mostly unaffected and continued to diversify in the early Cretaceous. Meanwhile, most sauropod groups persisted past the boundary, although some formerly successful lineages, such as the basal macronarians and diplodocids, would die out in the early Cretaceous, while Brachiosaurid diversity plummeted outside of North America. The Rabachisaurids and Titanosauriforms, meanwhile, would go on to great success. Ornithischians seem to have been relatively unaffected compared to the other dinosaur groups, with only a moderate decline in diversity at the Jurassic-Cretaceous boundary. Stegosaurs did begin their decline at this time, which also saw a great upsurge in ankylosaur diversity, possibly as they begun to replace the former group. The ornithopods and early ceratopsians were also not affected very much, with the iguanodontians becoming increasingly large and abundant through the early Cretaceous. Overall then, whatever the causes of this ecological downturn really were, probably a combination of climate change, marine regressions, volcanism and bolide impacts, the Tithonian Extinction event is a notable yet understudied episode in Mesozoic history. The precise magnitude of extinction is currently unknown, especially in light of our increasing awareness of the impact of incomplete sampling on the patterns preserved in the fossil record. However, it is clear that the Jurassic-Cretaceous extinction event, although severe in multiple groups, was not on the same scale as that for the so-called Big Five mass extinctions, and set the stage for the rise of the most successful Cretaceous animal groups, including titanosaurs, ceratopsians, iguanodontian ornithopods, Carcharodontosaurids, pterodactyloid pterosaurs, and various coelurosaurs, including modern birds. Another somewhat mysterious extinction event took place in the mid-Cretaceous and was far more localised, with this being the so-called North American Sauropod Hiatus, taking place during the Cenomanian stage between 100 and 93 million years ago. This alleged extinction event saw the disappearance of sauropods from the continent. First noticed in the 1920s, this gap in the fossil record was thought to have been the result of both competitive exclusion by ornithopods, which were supposedly better placed to take advantage of a boom in angiosperm diversity, as well as habitat loss due to the expansion of the Western Interior Seaway, although this has been contested more recently. During the late Jurassic, sauropods were highly diverse in North America, as represented by the stunning array of species preserved in the Morrison Formation. As outlined earlier, many groups of these animals persisted into the Cretaceous, although their fossil record globally becomes far more scarce during the first half of the early Cretaceous. This is true for North America as well, with only a few sauropod species known from before the Albion, such as the Brachiosaurid Cedarosaurus, as well as the Turriosaurian Mierosaurus. Interestingly, both Brachiosaurids and Turriosaurs survived in North America when they seem to have been on the decline elsewhere, with some of the youngest known members of both groups being represented here. Before the beginning of the hiatus, a few important species of sauropods are known between the Albion and the start of the Cenomanian. These include the Brachiosaurid Abidosaurus, an 18-metre or roughly 60-foot long high browser from the Cedar Mountain Formation of northeastern Utah, which is currently one of the youngest known brachiosaurids, in addition to the Somphospondylan Astrophocaldia, which is a relatively modest sauropod at almost 11 metres or 36 feet long. This genus was a contemporary of its much larger and more famous relative Sauroposeidon, which was by far the most massive of North America's mid-Cretaceous sauropods. Described as a huge gas-guzzling barge of an animal by Matt Weddell, the leader of the team that first named this genus, Sauroposeidon was one of the tallest known sauropods, potentially being able to raise its head to a height of 18 metres above the ground, being as tall as a 6-storey building. Originally thought to have been a brachiosaurid, more recent re-examinations have found that it was a basal Somphospondylan, a close cousin to the titanosaurs. The initial size estimates for this animal were based on its presumed close relative Giraffatitan, with an overall length of between 28 and 34 metres, or over 100 feet long, while weight estimates placed its mass in the region of 40 to 60 tonnes. Given its reclassification, these figures may now be inaccurate, but still this was one huge herbivore, which as a fully grown adult would have been immune to predation, although younger individuals would be vulnerable to the large Carcharodontosaurid Acrocanthosaurus. Meanwhile, potentially the youngest North American sauropod before the hiatus was the modestly sized brachiosaurid Sonorosaurus, although the dating of the holotype is uncertain, with dates ranging between 112 and 93 million years ago. Beyond this point, sauropod fossils seem to vanish from North America before returning in the Maastrichtian, although a currently undescribed sauropod vertebra from the Santonian age dead horse coulee member of the Milk River Formation, dated to between 86 and 83 million years ago, may demonstrate that these animals experienced a steep decline rather than total extinction. This decline may have been caused by several factors, including the loss of lowland fossil-bearing sites due to the expansion of the interior seaway, and perhaps also due to the new competitors in the form of diversifying hadrosauroids. Although these derived ornithopods lived alongside thriving sauropod populations on other continents, so this may simply be a coincidence. Aside from the Milk River vertebra, sauropods only returned to North America during the Maastrichtian, with the massive and successful genus Alamosaurus quickly becoming the dominant large herbivore in southern Laramidia, where it lived alongside the formidable giraffe-sized Asdarchid Quetzalcoatlus, which also thrived in the drier, more open conditions of this region. This marked the end of the sauropod hiatus in North America, although a similar event has been observed in late Cretaceous Europe, with sauropods almost vanishing from the fossil record between the late Coniacian and Santonian stages. All of this just goes to show that Mesozoic animals of all kinds were tough and resilient to serious environmental stresses, the opposite of older views, which saw dinosaurs as poorly adapted inferior species that needed wet tropical conditions in order to survive. The KPG extinction event was different, being a horrifying disaster of almost biblical proportions that struck down the vast majority of Maastrichtian megafauna. Thanks for watching, everyone. The next episode will be covering another patron request, with this being the enormous stag moose Servalces, a distinctive member of Pliocene and Pleistocene megafaunal communities in both Eurasia and North America, with one species being the largest deer to ever exist. See you again soon. Cheerio.